Practical work. So I'm going to emphasize the practical work that we have that the students do. They actually do. There's of course C programming under the GNU Linux environment. So I don't think I need to say much more about that to this audience. It's because I wanted to avoid discomfort between the students seeing the SUSE Linux distribution run on the lab machines natively, and then find themselves working with some other distribution that they install themselves. I chose to have them work with the same distribution in their experimentation that they use when they go, that they encounter when they go in the laboratory. It's not that OpenSUSE is best suited for this purpose. That's the reason. Since it's a shared laboratory on the internet environment, instead of the students, I think the optimal setup. Well, things might change. I might not say this in the future, but one would think the optimal setup for an OS lab is where each student has full access to the bare hardware. Well, this is on a network. We have to worry about security and all that. So we have VirtualBox images. The students create the VirtualBox image by following instructions that I've developed, by simplifying, develop them, and publish the instructions. Let me add at this point in the talk, that if you're anyone faculty member who might be teaching an OS course sometime now, did teach a course in OS, or will teach one in the future? Nobody? You maybe? Maybe. Okay, if there were such a person, maybe you were, you have to do it. So to prepare for the course in this manner, you actually have to go through the exercises, test drive them yourself. Otherwise, you're going to make a fool of yourself in front of the students. And they're going to waste time, and you're going to waste time. I've never had a grad student who would, at least here, who I could just say, all right, to become a hacker and show the students how to do it. Doesn't work. You have to do it yourself. So the students end up doing. What they end up doing is some semesters they actually built. In other semesters they copied and then modified an entire Linux kernel build tree. Then they rebuilt the kernel after making modification. The first modification we make them make is to add a system call. Nobody adds a system call to the Linux kernel for practical purposes anymore. But the reason, so there's no published interface in the module infrastructure for adding a new system call to the kernel. You can add a new system call from a module if you hack into the system call table. But I don't believe in teaching students to do that as part of an academic course. So we don't do that, we teach them the right way. And the reason for starting with that stuff is that it gets them into building the whole kernel, and it teaches them just how does a system call work. So the system call is the primary, current technology, system call is the primary main interface between user land and kernel services. So that's where you start. What's the interfaces is the important thing in systems. Okay. Then after that, they get into a more efficient way of putting their own tweaks into the kernel by means of a modern way, which is kernel modules. So we do that too. And then, aside from programming things where they change kernel functionality, write application programs, do experiments, we have them do treasure hunting or reverse engineering, where they search through, study, and make diagrams of a tiny fragment of the system based on actually reading the sources. We do direct them to refer to particularly the Beauvais and Cassetti textbook to give them a guide as to what to look at in the sources. But that's how it works. So let's see, how do I do this? I said space. Okay, so particular benefits to this component of the course, the laboratory. And some of these I extracted from written comments that were written on the interim course evaluations that the Blau Center now offers to faculty. One student said, that her people she worked with, said, Linux kernel hackers can make lots of money. What I see happening, and what I try to encourage in the laboratory is skills, two things, skills and confidence, which are really related, to focus on to focus into. You don't read the whole thing. You're not going to read the whole thing of millions of lines of code. You're going to solve a problem. To focus into huge code bases, typical of modern systems. The third, and I see this happening in the lab, people recognized it in a positive way, shall I add, in the course evaluations, to learn to use command lines and Unix utilities in a professional way. That includes doing things quickly. Not struggling to figure out how to write a command, to type a command in to do something. To learn to do it quickly so that it does not distract your attention from the more difficult things. So little tricks, like I personally am able to tell them how they should use file completion. Instead of typing a dozen characters to get at a thing, they should just press tab. Many of them just don't know that, this modern world of clicky mousing. Introduction to complex configuration control. How do you configure the kernel? Building a kernel, most people I think you would know this, to build a kernel you have to go through the so-called kernel configuration process. Of course you could say make old config and just get it over with, but they get an introduction to that. We teach them how the the .config file at the top of the kernel source tree. After you configure it, there's this file at the top that's named .config. In it, there is a whole slew of preprocessor defines, and those are fed into a header file. That's how the configuration settings get communicated to each of the compile steps in building the kernel. So they learn how that works. And then we expose them to the fact that that the concept that Sun advocated. Now Sun is now Oracle. They used to say the network is the computer, and they used to advocate that that the network be invisible. All the network workstations are all on computer. We know that if you care about performance, you better not understand things that way. So they become aware that there's a server in the back, there's a file server in the back, there's a compute server somewhere else, there's the PC in the laboratory that's on the network in it, and then when they go to the library to use the departmental server remotely, they know there's an X server running in the library computer. The workstations run X, of course, there's Unix, Linux systems that nowadays all use X Windows system. Oh, so they get that real, I press enter and it gives me help. It's not what, see, I'm not skilled with this, I haven't. So anyway, so we use Pro. So what I have here, say I have about 10 minutes, 13 minutes ago. So this slide represents, this slide has two links on it, which I'll click on. Two of the topics that are fairly modern, that the technologies that that developed in the open source ecostructure, open source ecosystem, which we use. It's supplement the stuff in the textbooks. For example, the direct rendering infrastructure is an infrastructure that's a fairly modern, 10 years old, 10, 15 years old. An infrastructure for communicating large amounts of data between user space and the hardware drivers and the memory maps, the mapped memory, the hardware drivers and the mapped memory regions of modern graphics cards. Rather than channeling all the data through a local network connection, a Unix socket, which is the only way data was channeled from user land, from an application process to the X server, when the X server architecture was first developed in the 80s. Now there's a system where the X server and the graphics card and user land processes can share a segment of memory. And so we teach them about that. Open source ecology is where it was developed. The other example I'll show you is, this is a paper published by staff of Red Hat, and if it comes up quickly enough, we'll see it. What? Well, when will they? Free Software Foundation accept the Adobe license. The Free Software Foundation advocates development of a free version of the PostScript, of the PDF tools. Okay, so I'll just show you the journaling flash file system. So I spent about an hour lecture walking the students through this presentation from our friends in North Carolina.